Okay, in this session, I'm going to talk about two things. Clustering we did, classification we did. The third one, I'm going to discuss about the associations. So let's look at how association rules, what is association rules, and how we can generate association rules. Right. Now, having said that, let's look at how do you find association rules. Now, compared to classification rules to association, classification means you can create a rule for a class attribute. That means your right hand side. In right hand side, we will always have the class. But in association rules, it can be anything. That's exactly what we are going to do, right? So if you use in that fashion, the number of rules that generate will be very high. So, and also like calculation will be, there are a lot of calculations you need to do to come up with this. So usually the two problems you have to face in mining associative rules are computation complexity as well as the resulting number of rules. So those are the issues. Right. So three things that we are going to discuss before we discuss how this works. First one is called support. What support means when you create a number of the set of rules, how many instances which will cover. So that is called support. And the item is one attribute value pair, which means if you take Outlook and let's say Sunny, you have attribute value pair, right? And when you take multiple, we call item sets. So the idea is we are going to create a set of rules which we have, which exceed the predefined support value. I will explain again with the example. So let's look at our weather date set. Now it's something like this. You look at with the item sets. So when I talk about the item sets, it's look like this, right? Item sets, it's look like this. So let me explain. So let me take, yeah, okay, red color, let me take. So let's look at first one item set. Let me explain one item means. So one item means when we say one items, sets, if you take one item sets, it's like we focus only on individual attribute value pair. So for example, if you take only the Outlook, you can have Outlook Sunny. So Outlook equals Sunny is one attribute value pair. Similar to that, Outlook Overcast. Outlook Rainy. Right? And let's look at the support. Now, when you say support, what it means simply, what it means, how many times Sunny appears. So if you take this one, how many times? We have 1, 2, 3, 4, 5. The support is 5. So this is 5. Outlook Overcast, 1, 2, 3, 4. Support is 4. There are 4 instances with Outlook Overcast. Look at Rainy, 3, 4, 5. Again 5. These are like one item sets. Now, similar to this, if you keep on doing this, you can look at other values as well. For example, temperature is hot. Temperature is mild. temperature is cool. So let's check how many times it appears. So hot 1, 2, 3, and 4. We have 4 instances. Temperature mild 1, 2, 3, 4, 5, and 6. So this is 6. Temperature cool 1, 2, 3, and 4. So these are the one item set. And within the bracket, we said the support, which means how many times this appears in the data set. Now, this is one item. So let's take 2 items. So 2 item sets. 2 item sets. So when you say 2 item sets, we can look for 2 values. So for example, I can say outlook equals sunny, and I will put comma. Temperature equals hot. How many times? Right? And then outlook equals sunny, and let's say humidity high. So how many times? So you can likewise, you can have many 2 item sets. If you try these 2, let's look at how many times. So I'm going to, erase all these. So let's look at outlook is sunny and temperature hot. Outlook is sunny and temperature hot. It's 1. Outlook sunny, temperature hot. 2. Right? So that's 2, right? So we can say the support is 2. Yeah, can you answer the last one? So can you give me the answer for this one? How many times outlook sunny, humidity high appears in the data set? So now if you move on to the next slide, you will see. So creating association rules, the first step is we'll get item sets, right? We'll get item sets. The next one is you look at the support. What you see is in the beginning brackets is the support. How many times it appears in the data set? So one item sets, these 2 we have already checked. Outlook sunny appeared 5 times, temperature cool appeared 4 times. Outlook sunny, temperature hot appears 2 times. Outlook sunny, humidity high appears 3 times. For example, if you look at here, outlook sunny, temperature hot, humidity high, plano appeared twice. So in total, with the minimum support of 2, at least if you have 2 instances, here are the number of sets we are getting. We'll get 12 one item sets, 47 2 item sets, 39 3 item sets, 6 4 item sets, and 0 5 item sets. So this is the starting step, which means we first look at the items. Now let's assume that how do you create the rules? So once you get this, each of these sets can be converted into rule set. So let me show you one, right? So let's take some 3 item sets. So let me take, so I will go to the next slide. So let's assume that, okay, we'll take this humidity normal, windy, false, players. These are like 3 item set. If you have 3 items, using 3 items, we can create 2 to the power 3 minus 2 to the power 3 minus 1, 7 potential rules. It goes like this. Now, to simplify this, let me take 3 item sets as A, B, C. Right? A is like humidity normal. B is like windy false. C is like yes. So when you create the rules, you have if and then. So if something, then something else. This is how we have to put it, right? So since we have 3 item sets, we can do it in 7 different ways. How? So here we can put A comma B. So if A comma B, we can say then C. You got my point, right? So we can say if A comma B, then C. Then A comma C, then B. B comma C, then A. So this is what you will see here, right? Then we can say if A, then we can say A comma. If B, then we can say A comma C. If C, then we can say A comma B. So this is what you see here. That's 6. Last one, it's empty here. If true, then we'll say A, B, C. So that's how we are getting. So if you're having n items, you can have 2 to the power n minus 1 potential rules. That's what it means. Okay. Any questions on this? Let me reiterate what is discussed. The idea that we were discussing is generating, yes, association rules. When we say association, we can create, rules with any attribute value combinations. So the first step is you select some item set. And each item set we convert into rule set. So that's what we are going to do. And that's what we example here. We have 3 item set. And since we have 3 item sets, we can generate 7 possible rules. And you can imagine for each and every attribute value pair, we can create rules. So we will get huge rule set, right? So that's how we generate rules in association learning. Okay, so having said that, right, let's move to the next one. So now we can calculate the accuracy. So we discuss, you start with the item sets, you create rules. Now you have to say, right, accuracy of this rule. What do you mean by accuracy? Accuracy means in this particular case, take this rule. We say humidity normal and windy false. How many times this happens in the data set? Humidity normal, windy false. Let me check. Humidity normal, windy false, right? That's what we are going to look at it in our data set. Let's go back. Right, this is my data set. So look at how many times humidity is normal. So we have humidity normal, windy false, humidity normal and windy false. Humidity normal, windy false. Humidity normal, windy false. Humidity normal, windy false. Right? And out of these 4, there are 4 instances. Out of these 4, how many times play is yes? 1, 2, 3, 4. That means 4 out of 4, which is 100%. That's what we have seen there. So if you go back, what it means, humidity normal and windy false, we have 4 instances. And then how many times it's players? It's 4. 4 divided by 4, it's 100%. This 4 is number of records you have. So likewise, you can calculate. And in this one, they have filtered out all the rules with 100% confidence and at least more than one support. At least you have 2. So you will get 3 rules with support of 4, 5 with support of 3, 50 with support of 2. Okay. Right. Any questions on this? Okay, if you have no questions, let me show you how we can do this in Weka, right? Like we did early, I'll go to Weka Explorer. Right? So let's take Weka Explorer. Go to Explorer. Right. Let's open up a file. So I'll go to C, Program Files, Weka 3.8.6, Data. Let's take with the nominal data set. I mean, you can use any. Now, we are going to talk about associations. Association means any possible combination of this. So we'll go to associate and we are going to use a priori, no change. Actually, you can change the values you need here. For example, how many rules you need to have and so on. So let me put something like 100 because I just want to see everything. And we can say minimum supports, everything you can put it here, but just I will put 100 rules. I hope you remember the confidence is the metric. And then let's see how many rules we will get and how it will calculate. So let me start running this. So we got 100 rules. So let's go back and explain what we have seen. So this algorithm is known as a priori, which is what I explained exactly how a priori algorithm works. So you can see that it's a minimum support is 0.1, at least one instance, and confidence at least 9. How many times cycles perform 18. And it gives you the information this we have already discussed. We have large one item sets, it's 12, two items at 54, three items 96. Then we have we have 96, three item set, four item set 64, 5 is 14. This is with the minimum support 0.1, right? So let me change this. Let me say minimum support. Let me put 2. That is 3 instances. Then it will be reduced. So let me say minimum support. Right. And this is what I have explained earlier. So when you say minimum support 2 instances, I explained the numbers. We have 12 one item sets, 47 two item sets, 39 three item sets, and 6 four item sets. And you can see we had 58 with the confidence is 100% accurate. 58 rules. So this is exactly what we got, right? Okay, small exercise for you. Now, I didn't explain like when this is very useful, and I have seen some of you have actually selected the best data set a problem like this. The frequent items or association learning is very useful in places like supermarket or market basket analysis, where if you are interested in knowing what customers purchase together. So if you go to dataset, there's a let me say supermarket dataset, which I think, right. So we have supermarket dataset. And in this one, if you perform the association, and remember when you're performing association, you have to carefully look at, depend on the number of rows you will get. If you take too many rules, it's not very interesting, right? So you have to limit the number of rules, and there are various ways you can do that. If I just click the same without any changing the parameters, and then if you start running it, it will take some time because this is take some time. So according to this one, the same parameters that I have selected the supermarket case, and this data set, what we have is what customers purchases, and it is very interesting to see what they purchase together. For example, you can see this one. Look at the first rule: biscuits, frozen foods, and fruits goes together, and you can see there are 788 instances. If a customer purchase biscuit, frozen foods, and fruits, and out of 788, you will notice they purchase bread and cake, which is accuracy is about like 92%. Very interesting rule. What it means, if customers purchase these items, then maybe you can propose these to purchase. This is one way you can actually look at in data. Similar to this, baking needs, biscuits and the fruits, then the bread and cake. Again, high confidence. Party snack foods, fruits, bread and cake. So you can notice that, it's very interesting to see what customers purchase together. And that will also gives you very interesting insights about the data. So this is very useful places like market basket analysis or in supermarkets. So if you're interested to see. So similarly in movie database, if you have a set of, if you have a set of data with people purchasing movies, maybe you can see what customers purchase together, right? By going through a data set like this. But I think you are now comfortable with the basics that we need to work in, data analytics part. So having said that, with this one, we will conclude the basics that I want to discuss with you. One thing that I would like to discuss is, for example, how you may compare multiple algorithms together. So let me briefly spend some time on this, and then I can explain about how we can use Python for data analytics. So in this one, I want you to talk about a little bit on evaluation. What do you mean by evaluation, and what are the things you need to know about the evaluation? So that part I will discuss very briefly, and then I will show you how this may done in Weka. Right. Now, we discuss about the classification, clustering, and association learning. Let's focus on classification, which is common problem. And very interesting and very useful problem to handle it. But the problem is now we have seen so far uh, there are many machine learning algorithms, and which one to select is a quite challenging. So in this part, I will talk about some of the metrics that we could use for this. So the question that normally we will ask under the evaluation is how predictive the model will learn. So which means we started with some data sets, and then we build models, and these models are built using existing data. What will be the predictive accuracy of these models for new data? So therefore, when you are performing or when you are evaluating your models, you should not use your training data to evaluate this, right? What it means, sometimes you might do is you can build a model and then you can evaluate on the same data set. No, don't do that. So it's very important. So what happens usually if you're not done it properly, you will get high accuracy in training, but then you will get very low accuracy on new data. This is called overfitting, right? Or your model tries to uh, exactly represent your training data. So this is also called overfitting. Some generalization is needed, right? So when you increase your model complexity, then usually your error will be get reduced, right? And the variations will be high. The variance will be high. So what we need is the balance of these two, bias and variance, which we call optimal model complexity, right? So our model should be complex enough to get very high accuracy. At the same time, we need to reduce the variance as well. Right. There are many evaluation measures. And then the question is how reliable our, predicted results, because the model is built on data and we are trying to predict on new data. So there are a few things that we can talk about. Classification accuracy, or we can say error rate, which is one way to measure this. But remember, you should not use training set accuracy. So let's discuss how we can make use of, data. Now, if you have enough data, we can say large data, then what we can say is we can simply divide the data as training and testing. So ideally, we can divide, if you have a large data set, we can divide our data set as training and testing. So usually you can say, okay, 2/3 of data for training and 1/3 for testing. This is ideal case, but you can use any combination of this. For example, this is like saying 67% we use for the training and then 33% for the testing. So what we do is we build the classifier using training, but evaluate on the test set. This is called train and test, right? Okay, that is how we did. If graphically I show you, it's like you separate the data set at training and test. You build the model on model and then evaluate on the training set. But actually, finally, you can actually combine both training and testing. You can build the final model. For the evaluation purpose, you can use this training set. Right. Okay. So if you have a unbalanced data set, you have to be very careful. Because if you have an unbalanced data, you have a large number of data for one particular class, and you don't have enough data for the other class, then you are tend to get high accuracy for the, when you have data for, you have high number of data for one particular class. So you get more accurate results for that, but not with the others. Whereas what we really need is we need to get the other class accuracy. For example, in medical domain, we know that 90% could be healthy, but 10% could be disease. But this is 10% is the interesting one, right? That is the case. So therefore, what you need to do is we need to balance the data set. So if your data is not balanced, that means if you don't have same number of instances for all the classes, then you need to make a balance so that you can remove the bias. So how do you do that? We can actually select the minority class. The same number of instances you can select for the majority class. So you can either upscale or downscale. Right. The next one is parameters. For example, the k nearest neighbor. So you need to import, understand how to optimize that. So how do you do that? Usually in 2 stages, you build the basic structure and then you optimize the parameter. So in that sense, dividing data set into 2 is not enough. So therefore, usually, if you have a situation like this, we should divide our data set into 3 parts as training, validating, and testing. So if I graphically show you that, we can discuss the same. Right. So once you finish the evaluation part, you should use all the data points. That I will stress in our next case as well. Okay, sorry about that. So we were discussing about the evaluation. So we can separate data as training and testing, but finally you should use all the data points. That's what I want to stress here. Right. Okay. So if I show you like how this is work with 3 different data sets, it's like this. So we can use 3 data points. Data set is divided as training, validation, and then final test. So there are 3 data points we can talk about. So the idea is we can use training and validation. So you build the model and using validation data set to evaluate. But then if you want to use the final model, you can use both training and validation to build the final model, and then you can get the final evaluations. Right. Okay. The last one, the cross-validation. Sometimes we don't have enough data points. When you don't have enough data points, dividing data set as training testing will not work. So whenever a situation like this, we will use cross-validation. And the common scheme for cross-validation is called K4 cross-validation, which means you divide the data set into K4s, right? And let me explain with the graphic here. So in cross-validation, you get the data set, you divide into set of equal data, So depend on the number of folds that you are going to select. So if the K is 10, let's say 10-fold cross-validation, you divide the data set into 10 folds and take one as the test and use the remaining as the training. So you build the model based on the remaining data set and test on this test data set. And this is you are going to repeat for all the folds. Right. So usually when it comes to cross-validation, the term we use for this is called stratified 10-fold cross-validation. And if you ask me why 10, it's commonly used. Extensive study shows that most of the time 10-fold cross-validation works. And then the stratification means the class distributions should be same when you're dividing data into folds. So that's what we call the stratification. And then you can, if you want one more step ahead, you can have repeated stratified cross-validation. It means something like you can perform 10-fold cross-validation for 10 times, right? So that's what I want to focus on here. Right, now with that said, I think now we have the basis that we have to talk about how we can perform multiple, comparing multiple machine learning algorithms. So let me go back to Weka again. So let me go to Explorer. So one way to do is you can open a file. So let me say I'm going to open with some data. Let me say program files, Weka 3.8.6 data, and then let me say iris dataset, right? Okay, this iris dataset I already explained. There are 3 different types of flowers. Based on these 4 attributes, we are going to build model. So let me create. Here are the test options. We can use training, testing, and everything like this. For example, earlier I said training testing, which is called percentage split. It says 66%. That means 2/3 of data we can get. Right, let me change this to decision tree. So I will going to choose, let me use freeze K48. Right, let me start. And here is the accuracy based on the training and testing. It's 96% accurate. And you can visualize if you want. And when you visualize, you will get a decision tree like this, right? So now we can focus on this one. So let's try another machine learning algorithm. Let me use K nearest neighbor. So let me use K nearest neighbor. I'm going to use IB1, which means simple nearest neighbor, which is K is 1. If you do the same, you can notice looks quite the same accuracy we got it. Yeah, as well. Let me choose another one. Maybe let's see, naive base, whether we can go for it. Okay, so naive base is slightly lower, 94% compared to this. Let me take another one. Let me take, what do you call, random forest? Let me see. Should it have 100 trees? Okay, random forest. So let me start. Okay, about 96%. So this is comparing 4 machine learning algorithms on the iris dataset, and you can see how it varies. But the number of data points is 150, which is sometimes you may not call it as a large data set. So let's try with the cross-validation. So I'm going to first choose cross-validation. We'll start with the decision trees. I'm going to use J48. Let's run. And remember, this time it will evaluate 10 times. The average we will get usually slightly less accuracy because it happens 10 times and we'll get the average accuracy. This is actually develop 10 models and then you will get the accuracy. And the next one is, let's use IB1, same 10-4 cross validation. So you can see it's about 95%, less than what we got with train and test. And I think this is good compared to train and test. Let me select NIBase. NIBase. It's again 96. Then let me try with random forest. So it's again 95% something, right? You see how this will, you can do this. So this is quite okay when you're doing one at a time, but this is a bit difficult, isn't it? So therefore, if you want to do this in a more systematic way, what we could do is we can do it in a experimental mode. Let me explain that. So I'm going to close this one, right? And I'm going to use experimenter here. So which is the second application, which is useful when you want to compare machine learning algorithms. So the setup is quite the similar. You can open up a data set. First, you will say it's new experiment. And then we can add data sets here. So let me open iris dataset. Oh, I select iris dataset here. And this side we add algorithms. So I will add, for example, J40, that is the decision tree algorithm. Right? Then I will add, let's say, nearest neighbor. And then let's say I'm going to choose NIBase. Remember, I'm using default parameters. And the trees, I will get random forest. Okay, we have one data set here. We have 4 algorithms, right? We have used cross-validation. That's all right. Did I miss anything? So now that I have select, I will go to Run tab. And I will say Start. So it will take some time because I asked it to run 10 times. Got about like 3 seconds, done. Now we can go to analyze. So when we analyze, we'll say experiment, which will load the data. And it says, okay, it load the 4 results. So let's click on perform test. And it will give you outcome like this. Let me briefly describe what this means. So this will show you the comparing 4 algorithms, decision trees, simple nearest neighbor, naive Bayes, and then random forests, right? And then you can see that decision tree accuracy is about 94%, 95%, 95%, 94%, more or less the same. So that's why we say you can see the worst case and the best case and the worst case scenarios are there. But when you look at statistically, this one shows you based on the t-test, it will say that there's no big difference among these results. So that's what it means, right? So this is the way that you can actually compare multiple machine learning algorithms. Right. Having said that, yeah. Let me explain one more time. So first one, you open the experimenter environment and you can click new, and then you can decide on the experiment type. You can train, test, still you can do. Then we can select the data. So let me select, let's say diabetes this time. Then we can select several algorithms. So for example, I will go with the same algorithms we selected, G48. And then we can use simple nearest neighbor. Then we can choose naive Bayes. Then we can choose random forest. So I have selected a data set, 4 algorithms. So then I'll move to run, click start. It'll take some time to run, and then you will get the answer. For the diabetics, it's take some time. Okay, it's done. It took around like 17 seconds to finish in my case. Let's move to analysis. So I will select the experiment. So you can see here the 4 result sets. I'm not going to change anything. I'm just going to click perform test. And you can see there are also the results looks the same, no change. Because trees, we get about 74.5. Nearest neighbor about 70, 75, and 76. No significant difference, although there are slight differences in the accuracies. No significant, no statistical significant difference among these classifiers. But just by looking at the accuracy, you might argue that, okay, random forest is the best, but statistically, I would say the results are more or less the same, although there are slight differences. Okay, so with that said, that will be end of what I want to cover about the Veka. So I want everybody to focus on this result set. In this one, labor negotiation data is used, and naive Bayes, decision trees, random forest, and nearest neighbor is used to comparison. The first one is what we have selected, and the accuracy for naive Bayes is about like 94%, whereas trees is about 79. Random forest about 88. Nearest neighbor is around 84. You can notice star here. So star means this is worst case accuracy. This is okay. What it means, if you have a star in a result, what it means that it's worst result, which means compared to this one, you can see there's a statistically significant difference between this result and all the other results, right? So these three, there's no statistically significant differences, but this one is worse than all the other three. And you can notice by looking at the accuracies as well. So you can see here 93%, 88%, 84%, which are quite similar, but this one is about 89, much worse than other classifiers. So what you can say is trees are not suitable for this data set. Interesting result, I would say. Right. Okay. Okay, if you look at this example, the results that we got in the comparisons, in this one, we have iris dataset and we applied decision table, random trees, naive base, oh no, it's base net, and then it's use a simple logistic regressions, logistic algorithm. And you can notice here V means statistically better than others, at least this one, actually comparing this one with the others. So if you compare this one with this, because this is the basic. So if you compare the rules with the simple logistic accuracy we get, here we have 92%. This is better than this. So V indicates when you have better result. Star is for the worst result. So which indicates that this is statistically better than this result. Right? Make a note of this. It's very important and it's interesting to see that. So you will have variance in your exam. Right. Any other questions? Right. So in this part, I'm briefly going to discuss the same dataset that we have used in Iris dataset and how we can do this in Python. And when we talk about Python, I prefer Colab. Right. So simply you don't have to remember all these commands, but let me briefly go through this. So in this particular example, I'm going to show you how you may use Python libraries to do the same thing what we did in Wake Up, but this is more on depend on your programming skills. So already I discussed that in Iris dataset, we have 3 different types of flowers. If you visually look at it's almost the same. You can't visually separate them unless you are expert in this. So in this data set, we get 150 flower samples with 50 each for each of these different classes. And then there are 4 features where you take measurements in the sepal and the petal. We'll get petal length and width, sepal length and width. So this is the data set where we have the 4 features together with the class label. This is how we set up the data set. Right. Now, loading data, you have to use in Python, you have to use codes. So here we are using, first of all, we wanted to use scikit-learn, the machine learning library. So which is available in So this is the library we normally or generally use for machine learning stuff, which comes with a lot of functionalities for performing classification, regression, clustering, even dimension reduction, model selection. I mean, there are quite a lot of things you can actually work. But my focus here is for classification problem. So like in Weka, scikit-learn also comes with existing dataset. So using this line, we are actually getting or loading the Iris dataset. So when we get the dataset, we'll print a dataset, and in the printing, you will see the data here. And then you will also have other information like target, that means a class variable, and the feature names or class names and so on, right? So as the first step, what we do is we separate our data with class labels, and that is what we do here. And we just observe the outcome in these 2 lines. So we load the data set, and then we separate the data in X and Y. X is our data and Y is our class label. Right. Then we visualize and see whether we can visually see or separate the data. So remember, I told you we have 3 different classes. If you take the first column and the third column of the data set, 0, 2 means first column and the third column. And this is how it looks like with a single color. So you can see there are 2 clusters, 2 groups is visualized, but we know that there are 3 classes, which means one class is easily separable from other 2. So that's what we can come in, but since we don't have color separation, we can't exactly say. So in the next code, we will discuss how to separate them into different classes with different colors. And once you do that, this is the outcome. So you can notice here, right? You can notice here, this is Setosa, Versicolor and Virginica. You can see Setosa is quite easily separable from other 2 classes. And this is what you see in the visualization. And this is training and testing like what we did earlier. So here we will divide our data set as train and test. And I'm actually setting the test set size as 0.33, 1/3 of the data I have taken as a test, and 2/3 we'll take it as train. Right. So here is the outcome. 100 data points for training, 50 for testing. Building model is straightforward. In scikit-learn, we have a method called tree, and under that we have to call decision tree classifier. So we select the decision tree classifier and we train the model and we display the model. So when you visualize the model, it looks like this, not like very simple as in Weka, but this is more informative, I would say, right? And here also one thing you can notice, the setosa is easily separable from other two classes. You can notice that one from here as well. So one data branch will be in one side, the other two in the other side, which is, this is separable from this side. This is also, you can visualize or confirm from the decision tree here. Right. And then what we do is, now once you have the data, we can calculate the accuracies. So in this particular case, you will see how to make predictions from the model, and you can compare with actual model. So what you see is, now we have 150 data points. 100 we take as a training, 50 as testing. So here we have 50 data points with predictions and actuals. And if you look carefully, there are some small misclassifications. So we can check the accuracy to see, for example, here we can see, here we have 1 and here we have 2. Some misclassifications are there. So if you calculate the accuracy iris on decision tree, it's about 0.96, which is quite the same accuracy what we got from Weka. And there are other measurements which I'm not going to discuss. Finally, to find the final model, we are going to use the whole data set, not just the training data. The training and testing division we do in experiments, but when you are going to create the final model, then we can put it into single. So final model, you will get both training and testing together and you build the decision tree. And this is what you are going to take, right? Or use for the predictions, right? Those are the things that I would like to discuss. With the time and also the complexity of this, I do not think we have time to cover that. But let's share the information that you need. Video with describe all the steps again like this. And then I also share the commands where you could try to understand the difference between the implementation in Python and the Weka. With that note, we will conclude our session. And if you go to the LMS, you will see I have uploaded everything that you need. And I'll put up the video. So I have put up all the topics that we have covered. So let me reiterate what we do. So I will have another assignment to cover this part. Other things I think we have covered, so there's no issue of those, but to cover the data analysis part and the machine learning part with Weka, I will have another assignment. And with that, we will conclude up to this point. So remember, just to conclude, so we have basic Python review in the very beginning, and also we discussed important the libraries. Then we also discussed a little bit about the database design part, ER modeling, ER model mapping, and then we did lab sessions using MySQL. And then we also have a session on software development. And then final about 5 sessions, we worked on 6 sessions actually, we worked on Weka and especially focusing on machine learning in Weka. So with that said, that's all from my end. And I hope that the content that we have covered will be useful, because this will be the only computing module in your program.